Welcome to this analysis of engineer Abubakar Bavakadi's expert guide on RCC slab construction. If you're planning your dream home, currently in the middle of a build, or just kind of fascinated by the sheer engineering that keeps a solid roof over our heads, you are in the perfect place. We're going to completely decode the structural mechanics of home building today.
Okay, let's dive into this. Right away, Herb Avocati hits us with this absolutely brilliant metaphor. The RCC slab is the heart of the building. Think about that for a second. We always tend to obsess over the foundation, right? But the slab right above you, it's literally like a living, beating heart. It physically protects your family from the elements, shielding everything you love while constantly managing and distributing unbelievable amounts of pressure day in and day out.
So here is our structural blueprint for today's explainer. 1. The heart of the building, the RCC slab. 2. Key types of slabs. 3. Crucial construction steps. 4. Common mistakes. And 5. Golden rules for quality. Let's get right into it.
Section 1. The heart of the building, RCC slab.
Just like a rock-solid foundation anchors your home to the earth, the RCC slab, which, by the way, stands for reinforced cement concrete, acts as this massive horizontal anchor right over your head. It's definitely not just a flat ceiling you slap some paint on and hang lights from. It's a highly active, working structural plate. It carries the literal and figurative weight of everything we hold dear in our homes. I mean, it has to safely support your family walking around, incredibly heavy furniture, massive overhead water tanks, and crazy weather loads, all while constantly transferring that immense weight outwards into the beams, straight down the columns, and safely into the ground.
And this brilliantly illustrates exactly how it pulls off that heavy lifting. It's really a marriage of two totally different materials working in absolute perfect harmony. On one hand, you've got concrete. Concrete is incredibly tough when it's squeezed. It handles what engineers call compressive stress like a champ. But it's super brittle if you try to bend or stretch it. And that is exactly where TMT steel comes to the rescue. The steel reinforcement handles the tensile stress, the pulling and the bending. Put them together, you get ultimate strength, safety, and a massive boost to the longevity of your entire building.
Section 2. Key types of slabs. Now, what's really interesting about this is seeing how engineers have categorized specific variations for different parts of your house. Because, hey, not every room needs the exact same engineering solution, right? First up is the one-way slab. This transfers its load primarily in one direction, and that's determined by the ratio of its length to its breadth. Then you have the two-way slab, which is usually for squarer rooms, sharing the load super efficiently in both directions. Next is the flat slab, a really modern, clean look that rests directly on the columns with zero traditional beams underneath. And finally, the cantilever slab. This is literally engineering magic. It's what lets your balconies and window charges extend straight out into midair, anchored firmly on just one side.
Section 3. Crucial construction steps.
Okay, this is where we learn how to properly nurture and grow this vital part of the building on site. The guide lays out 6 strict macro steps, and honestly, you need to treat this like a surgical procedure. Adhering to this exact sequence is totally non-negotiable for structural integrity. Step 1. Precise shuttering and leveling, strictly following the approved drawings. Step 2. Tying that TMT steel with the exact correct diameter and spacing. Step 3. Placing cover blocks and chairs so the steel stays perfectly suspended inside the concrete. Step 4. Installing the nervous system, basically, your electrical conduits and plumbing sleeves before a single drop of concrete is poured. Step 5 is the main event, pouring design-grade concrete with proper mechanical vibration to get rid of any air bubbles. And Step 6, the most critical aftercare, continuous curing.
So, the crucial point here is this specific window, 14 to 28 days. Once you pour that concrete, the chemical reaction that gives it its strength desperately needs moisture. You need a minimum, and I mean a strict minimum, of 14 days of constant water curing. But ideally, maintaining it for 21 to 28 days is the absolute secret to maximizing the concrete's strength and durability. If you rush this part, you are quite literally compromising the entire structure.
Section 4. Common mistakes. All right, we need to shift gears for a second and talk about bad habits. These are the terrifying mistakes you see on unsupervised construction sites that can induce a catastrophic failure, so be super vigilant here. Adding excess water to the concrete just to make it easier to pour? That completely destroys its final strength. Leaving a low steel cover means your internal reinforcement is just going to rust out over time. Poor vibration leaves hidden air pockets, basically turning your slab into structural Swiss cheese. Removing the bottom shuttering prematurely will literally cause the whole slab to sag or even collapse.
Neglecting the curing process we just talked about stops the hardening dead in its tracks. And finally, casting without a qualified engineer on site to oversee all this, that is just a massive recipe for disaster.
Make no mistake, if you are building a home, these are not just minor technical hiccups happening on a spreadsheet somewhere. These are direct, immediate threats to your family's safety and your financial future. These exact missteps are what directly lead to giant, terrifying ceiling cracks, that maddening water leakage during the monsoon, a huge loss of structural strength, and honestly, a drastic reduction in the lifespan of your entire property.
Section 5. Golden Rules for Quality.
So let's build on that and look at our ultimate blueprint for success, the lifestyle choices required for a long-lasting, healthy structure. Consider this your master checklist as a prospective home builder. Always, always follow the formally approved structural design. Absolutely no guesswork. Use high-quality cement, sand, aggregates, and authentic TMT steel. Maintain the strict water-cement ratio on casting day. Refuse to cast unless your site engineer is standing right there with you. Continuously check the concrete quality as it arrives. And of course, ensure proper, timely curing for those full 14 to 28 days.
I really love how Herb Havakati wraps up his guide. Strong slab, safe house, happy family. It perfectly captures the essence of all this engineering, doesn't it? A slab is never just concrete, sand, and steel. It is quite literally the physical protection over your family's heads. It shields your memories, your loved ones, and your biggest investment. So, as we wrap up this explainer, I want to leave you with one very provocative question to think about. Look up at the ceiling above you right now, or think about the plans sitting on your architect's desk. Is the future foundation of your house secure? Knowing what you know now about the engineering, the proper execution, and the immense dangers of cutting corners, are you ready to take charge and make sure the heart of your building beats strong for generations to come? Thank you so much for joining me to explore this today. Keep learning, keep building smart, and I'll catch you in the next analysis.